Okay, let's just get right into it. You've heard all the buzzwords, right? Agents, copilots, assistants, but what's the actual technical difference? For us as developers, this isn't just marketing fluff. This is a fundamental architectural decision. So today, we're going to cut through all that noise and give you a clear developer's guide.
So here's what we're going to cover. First, we'll talk about the big picture problem everyone's facing. Then we'll break down the single most important architectural split, assistance versus autonomy. After that, we'll get into the nitty-gritty of how these agent systems actually work, compare a couple of the top frameworks out there, and then wrap it all up with how you can make the right call for your own project.
So why is this conversation happening now? Well, a lot of senior architects are talking about this idea of the automation plateau. Basically, the problem isn't about making the models smarter anymore. We've got incredibly intelligent models. The real engineering challenge now is all about the system's autonomy.
And look, this really matters. This isn't just about vocabulary for a marketing slide. If you make the wrong architectural choice here, like building out a whole complex agent when a simple, well-crafted prompt would have worked, you're talking about a huge impact on your system design, your scalability, and your costs. Getting this right up front is absolutely crucial.
Okay, so let's get to the heart of it. The single most important concept to get your head around is this core architectural split. It's the difference between a system that assists a human and a system that acts for a human. Everything else we're going to talk about, it all stems from this one fundamental divide.
So on one side, you have assistive tools. Think about ChatGPT or a typical Copilot. They are fundamentally reactive. You give it an input, it processes it, gives you an output, and then it's done. It's completely stateless. It's just sitting there waiting for your next command with no memory of the bigger picture. An agent, though, is a completely different beast. With an agent, you don't give it a specific granular task. You give it a high-level goal, and the agent's job is to figure out the steps. It has to perceive its environment, create a multi-step plan, and then execute it, often using other tools or APIs, without you holding its hand and prompting it every step of the way.
And this table really lays out that architectural split in black and white. Your assistant, your copilot, totally stateless. Every prompt is a fresh start. An agent, however, has to be stateful. It needs a working memory to keep track of its progress toward the goal. So yeah, the analogy is perfect. An assistant is a reactive tool you use, while an agent is a proactive digital worker you delegate to. This quote just nails it. It's a total mental model shift. You're not using an agent in the same way you use a tool on the command line. You're delegating a job to it and trusting it to see that objective through from start to finish.
Okay, so we get the concept. Now let's see how that actually translates into a real system architecture. Because it's a whole different ballgame. We're moving away from just prompt engineering and into something that looks a lot more like state machine engineering.
Right, so an assistant is a straight line. Prompt in, response out. Done. An agent isn't a line at all. It's a loop. It's a continuous cycle. It's not a one-and-done transaction. It's more like a persistent process that's constantly asking itself, okay, what's next? Have I reached the goal yet?
And that loop is the engine of any agent. It's really just 4 steps, over and over again. First, it perceives, okay, what's the current state of the world? Then it plans, here's what I think I need to do next to get closer to my goal. Then it acts, it actually calls an API, runs a function, whatever. And finally, and this is critical, it observes, did that work? What happened? And based on that result, the whole loop starts over.
Now, when you're building one of these for real, in production, you usually think about it in these 3 layers. At the top, you've got the engagement tier. That's the front door. It's how the agent gets its assignments. In the middle is the capabilities tier. This is the engine room, the brains of the operation. It's orchestrating the tasks and deciding which tools to use. And at the bottom, the data tier. This is the agent's memory, and it's super important for learning and maintaining context.
And you can see here how it all connects. The power of an agent doesn't just come from the LLM itself. The real magic is the system built around it. It's this architecture that allows the model to leverage external tools, to call APIs, and to access that persistent memory. This is what lets it actually interact with the world and get things done.
All right, enough theory. Let's get practical. How are we actually building this stuff today? Let's take a look at the frameworks that bring all these architectural concepts to life in code.
In the world of agent frameworks, 2 big names you'll hear a lot are Crew AI and Microsoft's AutoGen. And they're interesting to compare because they represent 2 totally different philosophies on how to build these systems. Choosing between them really comes down to what you're trying to accomplish.
So let's break it down. Crew AI is all about role-based collaboration. You literally define a researcher agent that hands off its findings to a writer agent. It's perfect for automating structured business processes. AutoGen, on the other hand, is much more of a flexible, developer-centric framework. It gives you very granular control, and its killer feature is a built-in, secure environment for agents to actually write and execute their own code.
So the rule of thumb is this. If you're automating a well-defined, repeatable workflow, think of a process in your sales or marketing team, you'd probably lean towards Crew AI. It's built for usability and speed, meaning you can get something deployed faster with less boilerplate code.
But if you're tackling a more open-ended, complex R&D problem, something where the agent might need to adapt and write its own Python script to find an answer, that is squarely in AutoGen's territory. It gives you the power and flexibility for those custom, research-heavy tasks, but it does come with a bit of a steeper learning curve.
Okay, and now for maybe the most important part of this whole discussion. With all this cool tech available, how do you decide if you even need the complexity of an agent in the first place? Because honestly, this is where a lot of projects can go off the rails.
Before you write a single line of agentic code, you have to ask yourself these questions. First, can this be done in one shot, with one well-crafted prompt? If yes, just do that. Is the workflow completely predictable and rule-based? Then maybe a few simple API calls are all you need. You should only start reaching for an agent framework when the answer is a firm yes to questions like, does this system need to make autonomous decisions? And is a stateful memory absolutely essential?
And this is the biggest takeaway for any developer working in this space. The temptation to build a complex, multi-agent system for every problem is real. But if a good prompt or a simple script solves 90% of your problem, building an agent is just adding a mountain of unnecessary cost, complexity, and risk.
And we have to be realistic here. Neither of these architectures is a magic bullet. Both assistants and agents come with significant risks. You have to design for inaccurate outputs, you have to worry about users trusting them too much, and you have to engineer for reliability and security. These are complex systems that demand careful governance and human oversight.
So ultimately, this isn't a debate about which AI is smarter. That's the wrong way to think about it. It's a classic engineering trade-off. It's about looking at the job to be done and consciously choosing the right architecture for that job. It all comes down to deciding the exact level of autonomy your system truly requires.
So as you plan your next AI-powered feature, this is the strategic question to ask your team. Are we just trying to build a better, more efficient tool to assist our users, or are we truly architecting an autonomous digital worker that we can delegate a goal to? Your answer to that question will define your entire approach.